do a little experiment today, and we are going to use some rubber bands. So this is my data table. We're going to do 3 trials with each rubber band. I have this guy set up, my horribly complicated rubber band shooting machine, which is, ignore that guy. Basically, an old piece of wood with some screws sticking out, and I'm going to put rubber bands across it and shoot it across the floor, and we're going to measure what happens. So here we have the names I gave to the 4 rubber bands. So Skinny Red is this guy. Big Red is this guy. You can't see it so good, but he's really skinny and he's about twice as thick. Then we have Little Fat Blue Guy, and you can see he's a little bit thicker. And then we have a hair band, an elastic hair tie wrapped in thread, and used. It's got hair stuck in it. I found this on the floor. Quarantine science, everybody. Okay. I measured these. If you sort of fold them like this, the 2 red ones, Skinny Red, Big Red, are about 3.5 inches, 7 inches total length. If you cut them, which I don't want to do. And these 2 guys are about 2.5 inches. So I tried to make it paired so that we have a common length of rubber band here to see if it's just the thickness that's affecting flight distance. And here we have same length again, so that we can compare data from this rubber band to this rubber band to see if it's length, or this to this to see if it's length, this allows us to compare the data in a couple of useful ways. We'll talk more about that, but that's the intro. Let me set this up and start shooting rubber bands. Okay, so here's my experimental design a little bit. I borrowed my son's book, great book, To Kill a Mockingbird. Notice that I have the launch point lined up with the beginning of the tape measure. And we've got a little bit of an angle, but I'm going to try to keep the angle the same. I'm going to keep the angle of launch the same by lining up the edge of the board with the edge of the book. So that'll be my way of keeping that the same for all 12 launches. And we've got about 11.5 feet of tape measure. Based on my trials, we won't need any of that. I sort of tried to make it so I wouldn't need a 30-foot hallway. So when we do this at school, I think that this is a really fun experiment to do at school, because you can like sit in the hallway and shoot rubber bands down the hallway, and then you got plenty of room. I've got some pretty wicked rubber bands in my classroom that I can't use for this. I'm sort of frustrated. But anyway, so that's our experimental design. So experimental design, how did you set this up? What we're trying to test is how the different kinds of rubber bands are going to travel different distances. And I think that the thickness of the rubber band and the mass of the rubber band, how much it weighs or how much matter it has, is going to affect how far it flies. I don't know, is the skinny one going to go farther than the fat one? Are the little ones going to go farther than the big ones? Or the big ones are going to go farther than the little ones? I don't know. Let's try this. The procedure really is, I'm just going to take my finger and I'm going to ever so slightly, notice that it's right on the very tip of the screw, so just a little tiny nudge should shoot that guy. And it looks like our first launch is, let's go over there and read it. I should have turned the tape measure around. 66.5 inches. So notice I'm trying to read from the back edge right here. so that it doesn't matter if this got folded up or not. Notice if I read from this edge, then it's 66.5. If I read from this edge, it's 68, which makes a difference, right? Imagine that some weird stuff happened and it landed like that. And it'd be 70 inches, right? So the way it lands shouldn't change the data. Does that make sense? So you want to be as consistent as you can, and the folding of the rubber band when it lands shouldn't change your numbers. It should be about how far it goes, right? Not just like this rubber band is more rolly than the other one. Okay, so I'm going to write that down, 66.5. Okay, and you can see after I shot the rubber band a couple more times, my data wasn't super consistent. It went 66 inches and then 53 inches and then 77 inches. So that bothers me a little bit, but rubber bands are affected by a lot of variables that are difficult to control. So we're going to accept this data. This is why we did this 3 times, because random stuff can happen. I'm pretty confident that if I did this 20 times and averaged it, that I would get about the same average. Okay, maybe I'll check that if I'm bored at some point. Okay, so we're gonna keep going. Our next huckleberry, our next choice is, our option is this guy. This one is a little bit thicker. That's Big Red. That's Little Red. I think you can see the difference when I turn them. Big Red is about twice as thick as Little Red. I think you can see that pretty clearly. Okay, let's try this out and I'll let you know. Okay, so we got some sort of shocking data with Big Red. A bigger, heavier, fatter, stronger, thicker rubber band was supposed to go farther, right? What do you think happened? Well, let me show you something. On our launcher, notice that this rubber band sort of sticks out more where it's on the screw here. And I think what's happening is it's getting stuck on that screw, getting caught and not launching appropriately. So I think with the last one, you'll see that the last one went 39.5. Maybe that's the issue. So let me show you how I'm doing this. So this is trial number 4. See, that's happened to me a few times. So I think the data reflects the experimental design, right? So Mr. Coleman could go back and rethink his design to plan better for this rubber band. There's also some things that are affecting the experiment that we're going to talk about. And one of them is how you launch it. So we're going to move on in a second to the smaller rubber bands, starting with little fat blue guy. So you're going to see that how far you stretch the rubber band, depending on its original size, will change how much energy you put in and how much energy comes out. So let me ask you this. What takes more energy? To stretch this rubber band to here, or to stretch this rubber band to there? So you'll see I'm only adding a half an inch or so. I'm only adding a little tiny bit more, but I can barely do it with this strong rubber band beyond a certain point. The rubber band seems to take more strength to stretch the bigger you stretch it. Does that make sense? So to move it from just a little bit Doesn't take much. Whoop, 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 whoop. To stretch it a lot takes more energy, but more than just adding this and this. It's harder to go from here to here. It's harder to go from here to here than it is to go from here to here, even though it's about the same distance. I gotta pull harder to go that extra ½ inch than I do to go the first ½ inch. Because it's pulling back with more strength, more force. Its resistance is greater. Its elasticity. Interesting. So let's test this out and see what happens. All right, so you'll see here that the data might not have been what you expected with this rubber band. So he went really far. I don't know why it's a guy, but it is. He went 107 inches on average. He even turned right a little bit at the end. I might have gone a little further if I'd done this perfectly. But it's interesting that this little blue rubber band went way farther than this guy. Like 5 times, 4 times farther. Now the question is, how's this guy gonna do? Okay, so you can see the results here. The hair guy on the first trial took a hard left and went sort of AWOL about 24 inches to the side. So that was weird. But this time he actually went under the closet door and hit the vacuum cleaner, and this time they hit the wall. So I'm sort of estimating, based on what I saw, they might have gone another foot beyond this, 12 inches beyond this, but clearly this guy went the farthest, okay? So based on averages, we have a clear winner based on this launcher with these rubber bands. That rubber band went the farthest. So the rank by distance is exactly what you expected.